In the last video, we said that the default implementation of toString returns the object's hash code. So what is a hash code? A hash code is basically an identifier for an object. So an identifier for an object. Okay. Now in the last video, I actually said that it needs to be a unique identifier, but that's not necessarily true. And in fact, it will not be true in the example that we're going to describe later. Okay, but let's first see why hash codes are necessary. Let's suppose that we want to create a set of point objects. So remember how sets work. Sets are, set-based data structures, which means that they do not allow duplicates. So let's say we add the point, or we create a set and we instantiate it as a hash set. So remember that tree sets and linked hash sets impose an ordering to the elements. Okay, but imposing that ordering takes time. It's not just a quick operation. In fact, it can be very slow. So if you want to just have a data structure where you can query whether an element is in a set, or you want to, you just want to have some fast data structure for storing non-duplicate data, a hash set is your best bet. Okay, so let's add 3 points to the set. We have s.add new point 3, 4. We add the origin, then we add another new point 3, 4. So my question is, how many elements are in the set? Intuitively, we think, yeah, there's going to be 2 elements because we have a point here that has 3, 4. We have a new point which is at the origin. Then we have a duplicate point here. Well, unfortunately, that's not right. And I may have spoiled it a little bit by having a 3 here, but the answer is 3. And the reason why is because Java does not, or hash sets do not use why is this false? Or why is this 3? So you might be thinking, well, do the sets not use dot equals to compare for object equality? The answer is they do, but only after checking the hash code of an object. Okay? So what exactly is a hash code in general? Well, we get a hash code by something called a hash function. Okay? A hash function is some function x, you give it some input x, and it gives you some number in, some integer, some positive integer in. And basically this is used to determine whether an element is in a hashable data structure, like a hash set or a hash map. Okay? Now, you may still be asking, why do we not just use dot equals directly? Well, the problem is that dot equals can be very slow. What happens if, in the case of point, there's only 2 fields we need to check, x and y. But in the case of something larger, there may be a bunch of different fields to check, and some of these might even be recursive to check other things. Okay? So dot equals for a set is going to be, or dot equals for determining object existence in a set is going to be slow. Okay? So what do we do from there? Well, we can do something. We can just give or define a hash code function for point objects. Okay? So how exactly do we do that theoretically? Well, we're not going to talk about that, or we're not going to talk about it in detail. That's actually something that you'll do in a much later course. Well, not much later, in a subsequent course on data structures and algorithms. Okay, it's a little bit too advanced, but we can sort of brainstorm some ideas. Okay, but first let's talk about how to specify the hash code for an object. So how do we do that? Well, we first need to override the public int hashcode method. And again, just like toString and dot equals, you have to follow the header exactly. Public int hashcode with the uppercase C and the override. Okay? But again, the override is not strictly necessary, it's just nice to have. Okay? So now what? Well, maybe we can say that two objects are equal, or sorry, yeah, the hash code of a point might be defined as the sum of its x and y coordinates. Okay? And in fact, if we do this now, of course, this is going to be 2. Okay? But if we change this, of course, now you may think, okay, this is going to work. Because even if we change this, this is going to be 3. But the reason why this works is you might think, well, there might be a problem with this because the sum is going to be problematic, primarily because these two values sum to 7. They sum to the same hash code. Okay? And there's sort of a small issue with this. So if two things have the same hash code, Java will fall back on the dot equals method to see if they are the same. If they are not the same, then it will be added to the hash set. Okay? So this actually isn't a terrible way to create a hash code. I don't foresee any immediate problems. But let's see. So even if we reverse this, we get 4, 3. That's also fine. So in this case, I actually think this would work. I believe I said in class that this would not work, but this actually does. I'm pretty sure this does work. But in general, you shouldn't rely on it like this. So what you can do instead is use this nice method called objects.hash, and note the plural on the object. So what we can do is pass the instance variables of the class. Now you won't always pass all of the instance variables, but in this case we will pass all of them. Okay? In particular, if you have a recursive data structure in your class, like for example, if we had like a list of points in here for some reason, and then that list of points had another point, or had, like, for example, if there were, let's say we have a list of points here, so we have some point P1 which has this list of points, and then there's some point P2 in here which is some other point, of course, which has its own list of points, and then this stores P1 in it, so this is now here as well as here. It's inside of P2's list of points. So let's color this differently just to distinguish it a little bit. So P2 will have its own instance, its own list of points instance variable, but to compute the hash code of it, if we pass this list to the objects.hash method, we'll have to compute the hash code of every element in the list. That's how computing the hash code of a list works. So to do that, though, we have to compute the hash code of P2, which means we compute the hash code of all of its stuff, including the list, which means we need to compute the hash code of P1, which means that we're now in this infinitely recursing cycle, and we'll get a Stack Overflow error, and that's not good. So you won't always pass every variable to the objects.hash method. You should only pass whatever is needed to guarantee that two objects that are equal will have the same hash code. And in fact, that's a principle by Joshua Block in the book Effective Java. This is a very good book on Java programming and Java principles. I think everyone should read this. And just to restate the principle, two objects O1 and O2, or rather, if two objects O1 and O2 are equal according to dot equals, then they should have the same hash code. So object1.hashcode should equal O2.hashcode. Okay? So if two objects are equal according to dot equals, they should have the same hash code. That's how this principle is laid out. And indeed, we have that principle with this setup. Now, you may be wondering, what about the other direction? What if two objects have the same hash code? Should they be equal according to dot equals? The answer is, well, No, not necessarily, but we don't really care about that direction. Okay? Because two things could have the same hash code but then not be equal to each other. Sorry about that. I had to make a quick split there. But yeah, so two things could have the same hash code and not be equal according to dot equals. Okay? So, but again, we don't care about that direction. We only care about this direction. Okay? So let's go back to the code here and let's run this to see what happens. Well, of course, nothing will happen because I don't print out the size. Okay, so now, of course, this is 3, but that's because I made a small change here in the cut. So now, though, if we say that the 2 points have the same, if they have the same values, then, of course, the size will be 2. Okay, so again, remember earlier that I said that having the sum be the hash code result will actually be fine in this particular circumstance, but in the, for most classes, you should just rely on something like objects.hash. At least for the purposes of this class, you should rely on something that can give you the hash code for you. Okay, so that's the main selling point of hash codes, in that we can use them in hashable data structures like, for example, hash set and hash map. And another point by Joshua Block in his book is that if you override dot equals, you should always override hash code. A lot of Java tutorials and Java books do not do this, and that is egregious, because you have to be able to override dot equals, or if you're going to override dot equals, you really need to override hash code so you can use it in hashable data structures. Okay? A lot of data structures rely, and a lot of things in Java rely on the hash code of an object. So if you're going to override one, you have to override the other.